Hey there, everybody. Welcome back. We're doing 15.2 in Calculus 3, College's Sequoia's Fall 2022. 15.2 is on line integrals. We just looked at integrating with respect to a variable and not the arc length for a line. And where does that come in? When we're integrating a vector field. So our function is a vector field. Rather than using r as x, well, we're not going to just do the norm of dr regularly. When we're doing these function or vector field functions with the dr, it's easier to show them as what they are. F of x, y, z is some function in the x direction, another function in the y direction, another function in the h direction. Dr is dx, dy, dz. When we're doing the integral of, when we're integrating along x, the only thing we care about is the x component. So f will pair up with dx. When we're integrating along y, the only thing we care about is the y component. So we'll have g with dy. Same thing with z and dz. So one way of getting that is a dot product. If we dot f and dr, we get those things. So f dotted with dr, fgh dotted with dx, dy, dz, we get what we were just talking about. The piecewise or linear or the integrals with respect to each function. And we're integrating over a vector field now. I'll give an example in a little bit in the next video in physics where we do this. But another way of writing f dot dr, just as a reminder, if we evaluate it, we parameterize it, we got f of r of t dotted with r prime and t dt, and we go from A to B. Let's look at an example. We're going to do the function 8x squared yz, then 5z, and then negative 4xy. We'll do t squared, and t cubed for our r of t. And so t is going from 0 to 1. I rewrite f in terms of r of t. This is me showing them plugged in, each value plugged in. When you get that all worked out, you get 8t to the 7th, 5t cubed, and negative 4t cubed. R prime is 1, 2t, and 3t squared. So we're going to dot those two and then integrate them. So I showed the dot product separately. We get 8t to the 7th plus 10t to the 4th minus 12t to the 5th. They each have a dt with them now, rather than having the dx, the dy, the dz. So they can all go in one integral. We integrate that from t equals 0 to 1, and we get the value 1. So this is easier to do than doing log dx, and then log dy, and then log dz. Pretty easy. I'll give you an example in the next video. Peace.